Hello, I'm Brian Gelder, a scientist too in the Department of Agricultural and Biosystems Engineering at Iowa State University, and I'm here today to talk to you about the Daily Erosion Project and its work that it's doing through the Iowa Water Center to support the HUD Iowa Watershed Approach project. What is the Daily Erosion Project? It's probably the first thing I should start out with. The Daily Erosion Project is an estimator of soil transport and runoff depth from thousands of hill slopes across the state of Iowa and other Midwestern states. And it is also a presentation of these soil erosion and runoff estimates at the HUC 12 watershed level on a daily basis. So we might be asking why is soil erosion and runoff applicable to the Iowa Watershed Approach? Soil erosion and water runoff are very closely linked, and it's the water runoff that is estimated by the Daily Erosion Project that fuels the flooding process downstream, and it also contributes to long-term soil degradation and essentially the vicious cycle or positive feedback loop where degraded soils have increased runoff rates and experience increased erosion. The downstream impacts of soil erosion and water runoff degrade the water quality, and in the field, the soil erosion, the long-term soil erosion process, the excessive soil erosion process decreases land values as well as it reduces the productive capability of those soils. How is the Daily Erosion Project different from other available tools that are out there? The most common comparison is with USLE technology. This would include Russell and Russell 2 models. And these base soil erosion estimates on long-term historical average rainfall estimates. They don't do, they don't consider real-time spatial rainfall patterns in their estimates, and don't tailor their estimates to the intense localized rainfalls that typically happen in the state of Iowa and the surrounding areas. And so it doesn't allow us to estimate real time like we can with the Daily Erosion Project. We can in real time match the soil the precipitation process with a near real time database of soil and land management and topography to estimate every day how much erosion is occurring across the state and across the region. Our approach also allows us to easily do what-if scenarios, such as climate change scenarios. If we're having increases in intensity or frequency of precipitation, we can also estimate different cropping practices and added conservation practices across the land, and estimate what happens with between the interplay of those or with those changes alone. How does the Daily Erosion Project work? We start out with the Water Erosion Prediction Project model, a process-based mechanistic model of the runoff and soil erosion process. We give, we start out with information on the soils, and we start simulating the rainfall process on those soils, and we can estimate how much, based on tillage practices and residue cover, we can estimate how much is going to run off or infiltrate, and then the balance is left to run off. And as that water runs off, it also it has kinetic energy with it, and will also has the capability to carry soil and move soil downstream. So how do we what do we need for inputs to estimate this process? We are using NexRad precipitation in a 1x1 kilometer 2-minute time resolution product. We're also using high resolution 2-meter LiDAR elevation data sets that are capable of resolving conservation practices, but they also resolve roads and other features that we have to work with. We also use the 10-meter G-Servo soil survey product from the USDA to inform our soil properties. And we use field scale land use and management data that's updated every year. There's about 430,000 agricultural fields modeled in the state of Iowa. So we have, typically, a few hundred fields in every watershed that we're estimating on. And what do we estimate? We estimate crop growth and the water extraction by the crop and the residue cover produced by the crop, and we also estimate the runoff and erosion processes that are occurring in the landscape as the result of that precipitation. What does our databases look like for the state of Iowa? So we've got 1,647 Huck 12 watersheds in the state of Iowa. And this is, we have about 1,600 townships in the state of Iowa. So these are about the same size. If you're trying to figure out what the size of a Huck 12 watershed is, they're about the same size as a township, which is 6 miles by 6 miles. And we have about 37 million acres in the state of Iowa. So we're covering most of those acres using our 10-meter soil survey raster and our 2008 to 2016 cropland data layer and our late 2000s around 2010 elevation data and our 2009 crop-specific field boundaries that were determined in the development of the agricultural conservation planning framework. So what are we estimating, or where are we estimating on the ground for erosion estimates? We're estimating runoff, detachment, and delivery on the yellow portion of this arrow here. So we have our runoff process starting kind of at the base of that grassed area there, and we're estimating that runoff, detachment, and delivery along that area. And so we're essentially the delivery we're estimating is to the end of that yellow arrow. When we get to the black arrow, we're getting to where we have concentrated flow processes dominating, sometimes called gully erosion, ephemeral gully erosion. And these are where the mass flow of water processes start dominating the erosion process instead of the sheet and rill, more uniform erosion processes are occurring. So we just estimate what's up on the yellow portion, not on the black portion. So this is just a subset of the total amount of erosion damage every day. Now on the screen we have some examples of delivery, yearly delivery from the watersheds, the Huck 12 watersheds in the state of Iowa for 4 years. I'm kind of showing some wet years such as 2008, dry years such as 2012, and some more typical years, 2009 and 2016 was fairly more typical year as well. You can see the yearly dynamics of the soil erosion, amounts of soil erosion that are happening across the state of Iowa, and the spatial dynamics as well. In 2008, very wet year, so we had higher levels of erosion across the state. 2012, very low levels of precipitation, and we had very low levels of erosion across the entire state. Kind of follows what you would expect from those trends. And here we have a summary for our entire period of record of the average delivery from 2008 through the end of 2016. And you can see, the areas where we have high erosion are typically, are going to be the higher slope areas in the state of Iowa, western Iowa and eastern Iowa, and a little bit of south central or south central Iowa. This is also a combination of management practices as well, where we have, activities that are more tilling the soil more than we do where we have, grazing lands. That's going to increase those erosion rates as well. One thing to take away from this is, some areas of the state still are experiencing very high levels of erosion, even though the state is kind of down to what's considered tolerable, the 5 levels, 5 tons per acre per year, which is probably, which is still, is still going to degrade the soils over time. Some of these areas are still eroding up to, maybe around the 50 tons per acre per year on a watershed basis. Here we have on the screen now, we have an example from the Daily Erosion Project website where we've gone in to zoom into Worrell Creek of the part of the Squaw Creek drainage. Essentially the watershed that contains the state or the Iowa State University. You can see that kind of in the backdrop there. I've turned the opacity down a little bit, made the data layer a little bit transparent. And you can see the summary for the 10th of August of 2010. And you can see from our top 10 events, this is the highest, the #1 event for this watershed. And the day before it, August 9, was the #5 event. So you can see why we had some very severe flooding impacts in the state, or in the city of Ames on this day, just because of large amounts of rain the day before and the day of the 10th of August. This led to about, we had about 4.5 inches of runoff in this precipitation on this day, resulting in about 3.2 inches of runoff specifically in this watershed. And we had a lot of runoff from the watersheds above that as well. You can see, higher, even higher levels of precipitation just to the north of this watershed, causing a lot of the problems that we saw that day. The detachment levels and the hill slope soil loss levels, and so detachment is any movement on the hill slope. Doesn't have to be to the end of that hill slope, the end of that yellow arrow as we were showing before. So detachment would be any movement in that yellow area, and soil loss would be the total amount transported to the bottom of that, to the end of that yellow area. So the soil loss should always be a little less than your detachment, because you will have some movement that doesn't make it all the way to the end. These detachment and soil loss numbers are fairly low from what you would expect from a 4.5-inch rainfall on a fairly saturated soil, mainly because we had very high, very large. 10th of August we had full crop cover at this time period, so the soil surface was pretty well protected by residue and growing crops at this time. So it didn't result in lots of soil loss and erosion, but it did result in some significant flooding impacts downstream. And so from our left-hand side, you can kind of see we've got at the bottom of all of our pages, we have a summary of what's going on in that HUC 12 we're kind of looking at, and the information displayed at the bottom is where our mouse is currently at, whereas when we're in this information view, it's a watershed that we've double clicked at. So there isn't, you can see there isn't a total alignment between those two that we see there. We also, on the right hand side, then show the soil detachment numbers for that same date. So we went to the little leaflet portion of the menu and switched to the detachment view process, and you can see how much detachment was occurred on this watershed and the surrounding watersheds for that date. So I say go check out our website. There's additional things you can copy and paste these links to send these around. You can also download shape files of the data that you are looking at. So if you're doing a range query, which you can access through the wrench there. You can download for a summary period of record, or you can download for just an individual day. And you can also, you can zoom in and out, change the data layers that are being shown as the backdrop, change the transparencies as well. So we have a decent amount of flexibility for ways to visualize this product. So beyond these things, what can we provide for your watershed? We can do, as you've seen, we can do estimates of recent erosion under existing climatic and soil management conditions. So essentially, what's been going on, what's happened in previous years, going back to 2008 is our current limit in time. We're hoping that will be able to be moved back to probably the year 2000 or maybe a little sooner if we can, if the legal wrangling over the precipitation data is resolved. We're also, when we do this, we can do not just soil erosion, we can do detachment, we can do estimates of water runoff on these products. And we can also have a couple by request only things that we can do. We can do some precipitation profiling for your watershed, so estimating possible future climate climate impacts. And we can also do some soil texture maps and the changes, the estimated changes we've seen in water retention capabilities of soils in a watershed. So that's another product that we have. How do you request this information? To request this information, you should send an email to Hannah Bates at the Iowa Water Center. Our typical turnaround times are, around a week to a month, depending on how involved the data request is. We'll service you as fast as we can. Given our other commitments that we do don't do just the Daily Erosion Project, or we've got some other things going on as well. Other ways to contact us if you have questions about the research product and the processes itself. I would direct those to Richard Cruz, the co-leader of the Daily Erosion Project, or you can address them to myself. Both of our email addresses are there, as well as Hannah Bates, our output request contact. We've also got a Twitter and Facebook sites as well. So, and here's our link to the Daily Erosion Project. We're just dailyerosion.org, and that'll take you to our landing page, which shows all 4 maps every day, and then we have a map view where you can go in, map viewer where you can go in and query, do our specific queries that I was showing you in the previous slides there. Hope you're having a great day, and thank you for watching.